In this question, a 10 centimeter long rod carries a charge of plus 50 mu c distributed uniformly along its length. Find the magnitude of the electric field at a point 10 centimeter from both the ends of the rod. Let's understand this question with a figure. In this figure, we have a charge rod whose magnitude is plus 50 mu c and the length is 10 centimeter. This is a point P, and according to the question, point P is equidistant from A and B. So if we join it, AP and AB both are 10 centimeter. So we can say that PAB is a triangle and their magnitude is same. So it means it's the equilateral triangle. So all the angles are here 60 degree. Now if we consider our point A, so from here the direction of electric field is going away, and if we make the component of it, this is x-axis and here is the y-axis, and this angle is 30 degree because this is 60, so this is 30. So if we make the component of DE, so we will get DE sine 30 degree and DE cos 30 degree. Similarly, if we consider point B, so electric field is here, this is DE, and same thing if we make the component, we find that this is DE cos theta, which is 30 degree, and down we can write it as DE sine 30 degree. So these two component gets cancelled. So from here we can say that all the electric field is integration of DE cos theta. So here we name it, the center of the rod is O. So the length of the AO is 5 centimeter and OB is 5 centimeter. What is the length of OP? So it will become 5 root 3 centimeter. Now if we take a very small component or very small section of the rod, suppose this length is DL. So in this case electric field, which is equal to DE, it's equal to K into DQ divided by OP square. OP square we can assume as X. So it can be written as K DQ divided by X square. So what is the linear charge density? Linear charge density is equal to total charge per unit length. So from here we can say that Q is equal to lambda into L and dQ is equal to lambda into dL. So if we substitute this relation in the place of dQ, so we can write it as dE is equal to K lambda into dL by X square. And now if we have to find the electric field, it's equal to the integration of minus L by 2 plus L by 2 K into lambda into dL by X square into cos 30 degree. Now we can write it as E is equal to 9 into 10 to the power 9. Lambda is charge per unit length. So here charge is 50 into 10 to the power minus 6 and length is 10 centimeter into cos 30 is root 3 by 2 divided by x square 5 root 3 whole square into integration of minus L by 2 plus L by 2, and here it's L. So we can write it as E is equal to 45 into 10 to the power 4 into root 3 by 75 into 10 into 2 into L. So from here E is equal to 45 into 10 to the power 4 into root 3, L is equal to 10 divided by 75 into 10 into 2. So 10 cancelled. E is equal to, this is 9, here it is 15, 3, 5. So E is equal to 3 into root 3 into 10 to the power 3. But here our x value is in centimeter, so we have to convert to meter square. So we need to multiply with 10 to the power 4. So E is equal to 5.2 into 10 to the power 7 Newton per coulomb. This is the answer.